Using the code book to get your beam spans or your column spacing is basically what it gives you. But what you need to do is first look at your structure and figure out what that beam is holding. So in this particular picture, there is a center beam and it is supporting the floor joists in the middle. So there's two spans landing in the middle of landing on that beam. Up above it, you can see there's trusses and no bearing wall in the middle of the building. So in this case, that beam is supporting floor only. Okay, so that would be the table that you were looking for. If they were supporting floor and walls and roof, then that would apply to a different table. So we're always looking above to distinguish what we are supporting. Okay, so that is the table right there that you would be looking for. And maximum spans for a built-up floor beam. We're got to find the type of beam you're using and not supporting more than one floor. Note there's a couple little sentence statements there. They will be the fine print at the bottom of the table. And that is basically what we're looking for here. So in this particular picture, remember when we were deciding on how much weight was being pushed upon those columns, basically what you had to do was find half of this length and half of this length to distinguish what your weight would be transferred to the center of that building. So that is what you call a supported joist length. Okay, so it's always half of the span on each side of the beam. So whatever this span is over here, because sometimes they can be different, and half of that span there. Half of that distance and half of that distance gives you a supported joist length. So you got to add those two distances together, and that is what you have as your supported joist length. Okay, and then when we get into the tables, what it will tell you is this maximum distance between this post and this post, or the longest that beam can be spanned. So we can add more posts, obviously, to have a longer beam. When you get into the tables, first thing we got to do is basically you want to start at the right side and start with column number 1, and you want to find the lumber that we are using on site or whatever you might have. Douglas fir and hemlock, you don't find it in Ontario, so chances are we're using the SPF or spruce pine fir, and we'll have select structural or number 1 and number 2. That is basically our framing lumber. So depending on what lumber you have, that's where you're going to read it. So for this example, we'll say we have select structural because that table is not cut off in the picture. So we have a select structural. Then we find in column 3 our supported length or our supported length of our joist. So whatever those two spans ended up to would be our supported joist length. And for the sake of argument, we have a 3 meter supported joist length. So let's say there's 1.5 meters on each side of the beam. And then we can choose what size of beam we want. And that is right there. So you can have 3 2 by 184. What's that? 2 by 8s? Damn metric, eh? Anyway, so you go 3 2 by 8s, 4 2 by 8s, 5 2 by 8s, 2 by 10s, right? 3 2 by 10. So you would choose the size of beam we want. A 2 by 10 beam is a common size, so let's keep our cost down and we'll go with only 3 2x8s. And then we read that down in this column here. And 3.76 meters. 3.76 meters is our maximum span for the joint. So that means this post spacing maximum is 3.76. That's a lovely 3.76 meters in between those two posts.